All right, good morning, everybody. Thank you, Roberto, ASTA, Mogens, and Mats for warming up the crowd. I'm taking over here. I'm very pleased that I can finally talk in front of an audience again. So I've been on withdrawal for the last 6 months. So thank you, Roberto, for that opportunity. I'll be talking about smart resilience and what does that mean and what are the implications for autonomous systems. You'll see a few examples of our work later today. We have an autonomous bulldozer in the test arena. Make sure to ask them about the unexplained path deviations. Yeah, that was one of the fun results that came out of that, as well as 2 posters talking about our work on risk and safety assessment of cyber-physical systems, as well as the testing and validation of the robustness of artificial neural networks. So that is on the nerdier side, but we also look at organizational processes. We look at project management and risk management in the context of project management and innovation. All right, I can do this. Maybe I can't, Roberto. Here we go. Yes. Okay, I stole this picture from the CCAS homepage. So we're talking about collaborative autonomous systems today. Now, let me annoy you a little bit and make this interactive. Is that good news or is that bad news? Is this something that we should be excited about, or is this something that we should be afraid of? Yeah? So, excited? The crowd here is excited. I have one gentleman in the back who goes, yeah, maybe a little bit of both. So let's talk about this, maybe a little bit of both here, because to answer the question, is it good news or is it bad news? I think we also have to ask the question, well, what is it that we care about here? And if I put on my risk management hat for a second, there's something that we call the effect heuristic. And that means that if I'm totally excited about the benefits of something that I do, I will, or my brain will do that for me, discount the risks. The other way around also works. If I'm afraid of something, if I think it's very risky, I will also think that the benefits are very, very low. And you may have come across that in your professional career, where you're totally excited about something only to hit a brick wall with someone you're talking to who is coming from the exact opposite angle here. And public engagement was already brought up. How do we talk to policymakers? How do we talk to the general public? And I think they're having this risk-benefit conversation up front is very, very relevant. So I'm not overly smart, so things need to be simple for me to make sense. And here's my one picture how I make sense of the world. If I have to put it on one slide, this is it. So I would argue that society rests on 3 pillars. The first one is productivity. And we've been really, really digging into that for the last couple of 100 years, and we're very, very good at it. And I'm excited that we're good at it, because that affords us a high standard of living. Then, for the last 50 years, we've got excited about sustainability, and I think it was about time that we put that on the agenda. The third one is resilience. And I think that is the one where we don't have 50 years to figure out that is really, really important. In a nutshell, if something is affordable and if it is sustainable, it doesn't help us if it doesn't work reliably. And I think we've talked about risk perceptions in the break. I think we are spoiled in a good way as a society that our energy system works. Our food system works. Our medical system works. We're not worried about it not working. And now that we talk about collaborative autonomous systems, we have to make sure that we meet those expectations. And I think if we're honest, and what excites us as academics and thought leaders in industry is that, wow, this is great. It's complex. There's lots of new stuff going on that I can do my research in. And complexity means a larger amount of components and larger diversity of components and larger amount of relationships and diversity of relationships between those components. And if you're a risk guy, that gives you pause, because what you've just described is a whole new array of attack surfaces of how to screw up that system. So we have 3 goals that we're going for, and that's classic, engineering challenge. What do? You can prioritize. You can pick one of the 3 and say, It's all about productivity, it's all about sustainability, all about resilience. I don't care about the rest. And in some areas that makes sense. If you build a survivable, Navy large surface combatant, you want it to be resilient, you want it to be survivable, you don't care so much about how much it costs. There are compromises. You do a little bit of both, but that will also only get you so far. And I think what we love as engineers is to, look at these paradoxes, make them go away, and reconcile them. And that means innovation. And I think that's why we're here today and why we're excited. And I would put the proposition forward that it's not an option to be innovative here. If you want to do this, we must be innovative. We must reconcile these conflicting goals in a positive way. I'm using resilience a lot, so here's resilience on a slide. You see a pattern emerging. It's always three things on a slide. That's about where I can still follow my own argument. So we're looking at our autonomous systems being able to do three things: prevent disruptions, resist disruptions as they occur, graceful degradation. It's one of the keywords here. And then we want them to be able to recover and adapt. And we've already heard examples from ASTA this morning. The yellow box in the control circle is doing recovery and adaptation, fault-tolerant control systems on a very low technical level. But you can imagine how that also goes up to the organizational level. And could have a long conversation about where we need to put more attention these days. But why are commercial airplanes so reliable? It's because, we crashed a few, and every time one crashes, we have a global process that kicks into gear to recover and adapt around those challenges. Now, the title of the talk was Smart Resilience and something about service for society. So let's take a second to think about what does resilience mean from a societal perspective. So what is it that we care about as a society? And there are different ways of slicing and dicing the critical societal services cake. Here's one. It's sort of 8 areas where we argue if one of them goes down, our society goes down fairly shortly after. So that is things like energy supply, things like water supply. One that I witnessed was, our financial service. One of my PhDs works at Nets now. With my graduates doing risk management for our Dancourt payment processing. And I was in an underground car garage in Copenhagen when that system went down. So people could not pay anymore to leave the garage. How long do you have until people start punching one another in the face? I witnessed it, so I have an empirical data point here. Yeah, 5 minutes? All right. There was be careful with that guy, in a queue. It was about 20 minutes, 20 minutes. The guy in the front of the queue was convinced, no, I can't just drive out without paying. The 45 people behind him were like, yes, you can drive out of here without paying, because we've been here for 20 minutes. So it's great that we have these very rich lives, but we have to acknowledge that there are many ways in which it can go wrong. And the reason it doesn't go wrong is we had a long time to figure out how things work. But now we like to propose a radical departure and something totally new and something that's never been done before. And we have to ask the question, can we do that in a resilient way? And resilience for me means, we're not allowed to never screw up, but it means we're allowed to screw up a little as long as we learn from that and don't kill anyone or too many people in the process. So what are some of the critical hazards that I think are particularly relevant from an autonomous systems point of view? I think we have 4. Cyber threats is, I think, something that people talk about a lot, but I think they talk about it a lot for a reason. And that is that we're now looking at a very significant security safety cascade. So what used to be cyber threats where some computer went down is now some computer goes down, something explodes, and people die. So if you think that's sci-fi, Google the Triton attack on the national petroleum infrastructure of Saudi Arabia, and you think you're reading a Tom Clancy novel. But the attackers had the capability of blowing up the better part of the Saudi petrochemical industry for at least 6 months. They didn't do it, lucky for us, but it was a pretty hairy affair. And the that is not a singular event. And now we're saying, oh, collaborative autonomous systems, we're plugging in more vulnerabilities to cyber attacks. So is it okay to do that? Well, it depends, I think. And it depends on our capability of keeping the systems safe. We have climate change. I think that we have unprecedented and anticipated disruptions, because how does risk management work? We look at, has this happened before? No, so we don't care. Our COVID-19 pandemic, it's been 100 years. The nerds knew that this was going to happen, but does it mean we spent money on it, take it seriously? No. And it's going to happen more with the climate change-induced disruptions. We have the connectedness of our systems. I'm calling out our space-based infrastructure here, which is quite often overlooked, of how if somebody denies us access to that, our lives will change quite dramatically. You think your online banking system would still work when the GPS satellites go down? It probably won't. Or there's a chance that it won't, because we use these timing signals to keep the transactions safe. So that may shut down. And now we're saying, we're going to rely more on that. And by the way, we saw the nice hierarchy that ASTA introduced. There are a lot more interfaces here. And if one of them breaks down, the whole thing breaks down. And we have to figure out, I think, as designers of those systems, what are methods to put an architecture into place that is at least as robust as what we have right now. And then what also worries me is the speed of degradation, because of the connectedness of the systems and their global nature. When things start going wrong, they will go wrong real quick. And we've seen that the stock market, nice example of the whole automated trading, talking about collaborative autonomous systems. They're there for quite a while, and they've been a pain in the neck to get right. So we have to be, I think, very careful about designing these response cascades into our system so that the events don't outpace our ability to deal with them. That brings me to my last slide. Smart resilience. So what? What do we need to do? First of all, the bad news, it's not going to be cheap, but the good news is I think it's going to be a lot cheaper than not doing it. And I'm proposing to look at 3 areas here. One is people. So I think we have a responsibility to lead the national conversation on those topics. Because I think as people with a technological, the understanding of the nitty-gritty bits of the technology, I think it's our job to contribute to that, and ask questions. What are our resilience targets? What cost are we willing to accept? Talking about trade-offs. What are our thoughts about privacy and surveillance here? Because it's great to think about a smart city with autonomous drones monitoring everything 24/7, but they're also monitoring me as they go about that. On the process side, I think I would call it resilience management. So what are resilience assessment frameworks when we talk about collaborative autonomous systems? We don't even have established frameworks for safety analysis. It's something that we're working on right now to make effective across sort of the cyber-physical domain. So there's a long way to go for a systemic sort of resilience perspective to be practical. How do we design for it? It's just like other emergent properties of complex systems. It's not just one component that you can tweak and then it's safe or resilient or capable or affordable. No, it's lots of different things that need to come together. And so this is a classic systems engineering challenge, how to design for that particular emergent property. And then our operational processes around it, because it's not just the system, it's also how we design it, the system, and the human processes around it that are informed by those systems and supported by the system. So how do we run that? And then, last but not least, our smart systems capability. So getting back to the nitty-gritty here, what are things where autonomous systems can help us? Real-time situational awareness is a great one, because we make lots of bad choices if we don't have situational awareness. And autonomous systems can go into dangerous, dirty, dull areas, and they don't care. They will get us the data. Early warning systems. It sounds like a military thing, and it is, but it can also be around sort of climate change adaptation. It can also be around issues in our energy grid that we need to take care of. And then, at the very basic level, the questions around data acquisition, fusion, and analysis. I know we've been doing it for a very long time, but if you're in that space, with the new technologies, let's just put artificial neural networks out there, this is still a very, very hot topic for research. How do I validate them? How do I reconcile competing interpretations of the data done by different analytical systems and make that useful for a decision maker, either a human or an automated system? All right, and with that, I thank you very much. If you're interested in more, check out our website. I should say like and subscribe. I think that's what you do these days and on a webinar, but appreciate your attention, and I already appreciate the discussions that we've had here so far. So thank you. Yeah.
Please stay. I would like to welcome some questions from the floor or from the chat, if any. Then I have a question for you. This aspect of resilience, of course, I see it very central for the development of autonomous systems. And you have presented us that resilience is not only at machine level, but of course should be built across the different layers. Of course, within organization, and then, of course, ultimately in society. How, based on your experience so far, how far are we into this process? Is it something that is still very new and people have not really considered, or there is, so to say, already something going on because of this emerging awareness of new technological trends coming up?
Mm-hmm. It's a good question, Roberto, and I think the answer is both. Yeah? On the one hand, there's a lot going on around resilience, and for a while. Sort of resilience of critical infrastructure. We've been looking at that seriously for at least 10 years. But what I'm missing is that we start drawing conclusions from that, and that we feed it back into the design process of those systems. And we always treat it a bit of a sort of after-the-fact discovery if it is resilient or not. And then we look at an existing system, oh yeah, we need to tweak it a little. Fine, but I think we can do better. I think, especially if we talk about collaborative autonomous systems, where it's not quite a green field, but a greener field than most, where I think we have the opportunity and obligation to get it right from the start, because everything else will be not just expensive, but also, let's say, detrimental to public support. Sort of imagine you push autonomous systems to support some kind of sustainability agenda and deploy large offshore wind fields because we can now maintain them autonomously, and it doesn't work. Yeah? I mean, good luck getting re-elected on a sustainability agenda sort of next time around. And I think that's our job, that we need to take those insights and start using them now in the design process.
Yes. Please. Yeah, please.
Hello, Jacob from Lloyds. DTU, they have put up for all students, I guess, an LCA course for all students, so they need to go through and understand the issues about components and lifetime analysis on the impact on society, on resources, etc. I think that's a course that every student at DTU must go through. So maybe one could make a similar course in a risk assessment, or in the ability to understand when you have a system, either as a civilian engineer, building engineer, chemical engineer, or electrical engineer, whatever branch you are in, that that you bring these sorts in your design from the beginning. So again, like the LCA course, this would be a basic course for all students. Thank you.
Should I comment on that? You're putting me in a difficult position here, because on the one hand, I agree violently with what you're saying. On the other hand, no professor raises their hand and says, oh, I want to do more teaching. Yeah? Oh, few do. But I think it's a really good point, and we just have to start reflecting on, are we adequately covering that side in our teaching in general, and then asking ourselves, to what degree should that also be a foundational aspect? I don't think it's completely absent, So to be fair, I think there are aspects of it, but I think we can be more forceful and structured around it, yes.
Following up on this, maybe our new head of studies for the Autonomous System Master Program could consider the introduction of such a course. Maybe not mandatory, but we could have an activity on risk assessment, risk design. What do you say, Lazarus?
Thank you for a very nice talk. I strongly believe that this triangle that you have shown us is pretty important, and I think I'm coming from DGU Electro, and we are always so excited about our technology that we want to just deploy it. So in the scale, like good news or bad news, we're definitely on the optimistic side of this. But I think this should be something that we keep in mind. And that was actually a brilliant suggestion. I would agree. Also, it shows how autonomous systems is a topic that goes beyond electro, beyond management, beyond compute or space or aqua, and that it's only the synergies, and we couldn't offer this course. So it's actually, I take it as a opportunity for a very close future discussion.